For the last few years, scientists studying data from the James Webb Space Telescope have functioned as standard cosmology's unintentional gadflies. As you've heard on this channel repeatedly over a course of years now, JWST has and continues to reveal celestial objects whose apparent age, size, complexity, and chemical composition is totally incompatible with the conjectured conditions in the so-called early universe. We're still in the first month of 2025, but I couldn't feel any more comfortable predicting that the paradigm-shattering surprises will only continue and likely accelerate throughout the coming year. An early affirmation of this prediction has come in the form of yet another problematic, if not impossible, galaxy, with this one supposedly having formed at the tail end of the so-called cosmic dawn. This one is an apparently massive, grand design spiral galaxy called Chžulong, named after the mythological Chinese torch dragon. The galaxy was discovered as part of JWST's panoramic survey. The clearest problem for standard cosmology is simple. Galaxies of this sort have no business existing just 1 billion years after the theoretical Big Bang. A Science Alert report on the discovery describes it as follows. Back when the universe was new, following the Big Bang some 13.8 billion years ago, galaxies took a bit of time to assemble themselves from the surrounding primordial soup. A new discovery right at the end of the cosmic dawn is challenging how long we thought that assembly took. JWST has spotted a huge, ultra-massive galaxy as it appeared 12.8 billion years ago, so intricately structured that it can only belong to the most spectacular category of galaxies, the grand design spiral. The team leader studying the data is quoted as saying, Chžulong shows that mature galaxies emerged much earlier than expected in the first billion years after the Big Bang. Our finding offers key constraints for models of massive galaxy formation and the origin of spiral structures in the early universe. The conventionally mind-bending rate at which the object is thought to have formed is characterized as follows in the Science Alert report. The researchers believe that Chžulong represents the earliest example of a spiral galaxy seen to date. This suggests that a Milky Way-like galaxy can form far faster than we thought, around 10 times faster than such formation would take place in the local universe. Now, before I discuss galaxy formation in our electric universe in more detail, let's take a look at the primary reason that JWST data has been so problematic for standard cosmology. The belief in a Big Bang expanding universe has always been tied to the standard interpretation of cosmological redshift. In this view, the expansion of the universe causes light traveling through space to stretch, increasing the length and redness of its wavelength. Thus, the greater its redshift, the more distant the object. In contrast, the electric universe has always subscribed to Halton-Arp's thesis, which proposed that redshift is intrinsic and not due to an expanding universe. As noted many times here, in Arp's thesis, quasars are ejected from active galactic nuclei and can evolve into companion galaxies in quantized redshift steps. In such cases, the highly redshifted objects indicate their youthfulness. In other words, when astrophysicists view what they perceive as the most distant objects ever observed, many billions of light years away, they would do well to consider the warning that appears on a car's rearview mirror. Objects may be closer than they appear. The evidence for this, which Arp and other astronomers began presenting several decades ago, includes, quote, impossible connections between high and low redshift objects. That is to say, redshift cannot be due to a modification of the light on its journey to Earth. In Wal Thornhill's final contribution to the Thunderbolts project, he underscored an especially powerful recent affirmation of this point from the JWST images. As he explained in an in-depth analysis on the influence of cosmic dust on the visibility of celestial objects in astronomical images, the JWST has confirmed, as Arp always contended, that this image of Stephan's quintet clearly shows a quasar whose redshift in standard reasoning places it at 10 billion light-years from our perspective on Earth, in front of the galaxy NGC 7319. Whose redshift places it at only a few 100 million light-years away. Now, on the question of how galaxies form, let's take a look at what JWST has told us about the hypothetical role of dark matter in supposedly shaping the galaxies in the so-called early universe. Early in 2024, the Swinburne University of Technology issued a press release entitled Beyond What's Possible, New JWST Observations Unearth Mysterious Ancient Galaxy. The report begins, our understanding of how galaxies form and the nature of dark matter could be completely upended after new observations of a stellar population bigger than the Milky Way from more than 11 billion years ago that should not exist. A paper published today in Nature details findings using new data from the James Webb Space Telescope. The results find that a massive galaxy in the early universe, observed 11.5 billion years ago, a cosmic redshift of 3.2, has an extremely old population of stars formed much earlier, 1.5 billion years earlier in time, a redshift of around 11. The observation upends current modeling, as not enough dark matter has built up in sufficient concentrations to seed their formation. Now consider the remarks of Associate Professor Claudia Lagos, who contributed to the effort of the dark matter modeling for the scientific study. She stated, galaxy formation is in large part dictated by how dark matter concentrates. Having these extremely massive galaxies so early in the universe is posing significant challenges to our standard model of cosmology. This is because we don't think such massive dark matter structures as to host these massive galaxies have had time yet to form. More observations are needed to understand how common these galaxies may be, and to help us understand how truly massive these galaxies are. I can't underscore the following statement strongly enough. There is no direct proof that dark matter exists. Valuable resources continue to be spent on the search for dark matter, and with investigators coming up empty-handed, the number of professional scientists who have suggested giving up the fruitless chase has only continued to grow. And yet institutionalized science cannot claim that alternatives to dark matter do not exist, which are worthy of exploration. Of course, this goes beyond the well-known modified Newtonian dynamics. Longtime viewers of this channel surely remember retired Professor Dr. Donald E. Scott's mathematical modeling of a Birkeland current. Dr. Scott has compared the measured stellar velocity profiles in the arms of spiral galaxies with the predicted profile of a Birkeland current, the results of which you can see on the graph on your screen. As longtime members of the EU community know, it was many decades ago that plasma scientists began reproducing the evolution and form of galaxies through simple experiments with electrical discharge. The aforementioned Anthony Peratt recreated barred spiral galaxies in simulations with interacting twin current filaments, as seen on your screen. The IEEE Transactions on Plasma Science also later published Wal Thornhill's treatise on electrical star formation and supernovas as electrical discharge. Make no mistake, a foundation of peer-reviewed literature exists from which a new and better understanding of galaxy and star formation can be built. However, as already stated, institutionalized science has gone in a very different direction in response to the countless surprises provided by JWST. As Wal Thornhill predicted in his final contribution here, astrophysicists have been playing games of ad hocery, adding yet more epicycles to the Big Bang story, including the proposed doubling of the age of the universe to 26 billion years old. Now, I'd be remiss if I didn't mention that JWST is not the only source of data that is regularly undermining the Big Bang Standard Model. The morning of this recording, January 17th, Phys.org has published a new article entitled, Turning the Hubble Tension into a Crisis. It states, the universe really seems to be expanding fast, too fast even. A new measurement confirms what previous and highly debated results had shown. The universe is expanding faster than predicted by theoretical models, and faster than can be explained by our current understanding of physics. The discrepancy between model and data became known as the Hubble tension. Now, results published in the Astrophysical Journal Letters provide even stronger support for the faster rate of expansion. Now, the article features the following quote from the paper's lead researcher. The tension now turns into a crisis. This is saying, to some respect, that our model of cosmology might be broken. Now, the evidence for this crisis, which has been self-evident to members of the EU community for decades, is now coming so fast and furiously, it's becoming increasingly challenging to even document. Just a few days ago, on January 13th, The NASA Hubble mission team issued a press release entitled, "Hubble reveals surprising spiral shape of galaxy hosting young jet." It states, "Quasars are distant galaxies with supermassive black holes, surrounded by brilliantly hot disks of swirling gas that can blast off jets of material." Following up on the groundbreaking 2020 discovery of newborn jets in a number of quasars, aspiring naval officer Olivia Eichenbach of the United States Naval Academy has used NASA's Hubble Space Telescope to reveal surprising properties of one of them. The article quotes Eichenbach as saying, "The biggest surprise was seeing the distinct spiral shape in the Hubble Space Telescope images. At first I was worried I had made an error. If we looked at this galaxy 20 years or maybe even a decade ago, we would have seen a fairly average quasar and never known it would eventually be home to newborn jets. It goes to show that if you keep searching, you can find something remarkable that you never expected, and it can send you in a whole new direction of discovery." Now, as always, astrophysicists can only look at mechanical explanations, such as galaxy mergers or, quote, mashups, to explain quasar jets. As the NASA press release explains, some astronomers suspect that quasar jets are triggered by major galaxy mergers, as the material from two or more galaxies mashes together, and heated gas is funneled toward merged black holes. Spiral galaxy quasars, like the one whose name appears on your screen, however, suggest that there may be other pathways for jet formation. On this last statement, the press release is absolutely correct. That other pathway is succinctly described by Wal Thornhill in a synopsis of electric galaxies on the HoloScience website. He states, "For more than 10 years, plasma physicists have had an electrical model of galaxies. It works with real-world physics. The model is able to successfully account for the observed shapes and dynamics of galaxies without recourse to invisible dark matter and central black holes. It explains simply the powerful electric jets seen issuing along the spin axis from the cores of active galaxies. Recent results for mapping the magnetic field of a spiral galaxy confirm the electric model. Cosmologists cannot explain why spiral shapes are so common, and they have only ad hoc explanations for galactic magnetic fields. More recently, intergalactic magnetic fields have been discovered, which is the final straw to break the camel's back. Incredible gravitational models involving invisible black holes have had to be invented in a desperate attempt to explain how the attractive force of gravity can result in matter being ejected in a narrow jet at relativistic speeds. Why do we accept such science fiction as fact when an electric universe predicts spiral shapes, magnetic fields, and jets? The cosmic magnetic fields simply delineate the electric currents that create, move, and light the galaxies. And with that, let us hope that 2025 will be a year in which cosmology lives up to her name as the queen of the sciences. And much more importantly, let us each do our part to ensure that 2025 is an infinitely more sane, peaceful, humane, and compassionate year than its predecessor for all members of the human family.